Okay, we have one more function to test for symmetry, and then we'll graph it. This is very similar to number 6. So we're going to start by testing for x-axis symmetry. So to do this, we have to plug into negative y equals absolute value of x minus 1. And we can multiply both sides by negative 1. We get negative x minus 1. I'm sorry, negative absolute value of x minus 1. That's what I meant. So we compare that to our original up here, and obviously those are not the same thing. So this is a no. Okay, y-axis. So for y-axis, we plug in negative 1. I'm sorry, negative x. Just lost my train of thought. So absolute value of negative x minus 1. There's not much there that we can do with that. Yeah. So just compare it to your original one, and it is not the same thing. All right, so let's test for origin symmetry. So we have to plug in negative y and, equals negative x. And again, if we want to multiply both sides by negative 1, we can. But again, that is not the same thing. So this is a no also. So this does not have any symmetry. So we're just going to have to graph it. We'll just have to pick points, graph it. Hopefully we do a good job of that. Hopefully you recognize this absolute value. Absolute value graph should be V-shaped. So, but we'll just pick some points. We'll start with our standard, negative 2, negative 1, 0, 1, 2. If that doesn't give us what we expect, or if it's not enough points, we'll just pick more. So we plug in negative 2. Negative 2 minus 1 is negative 3, but then we have to take the absolute value of that. Plug in negative 1. Negative 1 minus 1 is negative 2. Take the absolute value. Plug in 0. 0 minus 1 is negative 1. Absolute value. Plug in 1. 1 minus 1 is 0. Plug in 2. 2 minus 1 is 1. Okay, so we've got negative 2, 3. Negative 1, 2, 0, 1, 1, 0, and 2, 1. And you can see the V shape is starting to take place. If you want another point, you can plug it in. But we're getting that shape. This is a V shape. Absolute values are V shape. Sorry about missing all those points. Now, you can take a look at this, and obviously this graph does have symmetry. Okay? It has symmetry here about the line x equals 1. So, x-axis, y-axis, and origin symmetry, they're not the only ones, but they're the ones that are most useful to us when we're graphing. So just so you know, there are other symmetries like this, for example, but we don't have tests for those. Okay, the last thing that we're going to talk about is circles, and I know you talked about this in geometry, and I know you talked about it in Algebra 2, but this is the equation of a circle. The center is HK. So in the equation, we have minus h minus k. Those are opposite signs. And radius r, and that goes here, r squared. So at number 8, the point 1, negative 2 is on a circle whose center is at negative 3, negative 5. We want to know the equation for this circle. Okay, so our equation is going to look like this. Squared. Okay, and we know our center. Here it is. So this is our h and k. So we can go ahead and plug those in. We have x minus negative 3 squared plus y minus negative 5 squared equals r squared, which we don't know r yet. So we can clean that up. X plus 3 squared, y plus 5 squared. Okay, only other thing we need to know is r. So, boy, let's think about this. So we have a center at negative, oh, that was supposed to be a graph. Let's try that again. 1, 2, 3, negative 3, 1, 2, 3, 4, 5. So here's our center and the point 1, negative 2. Okay, so our circle looks something like that. That's a really bad one. Okay, the radius is that long. So all we need to know is the length, or the distance, between these 2 points. So we can just use the distance formula for that. So our distance formula is x minus x squared, I'm going to move that over, plus y minus y squared. So let's see, plus plus, so that's 4 squared, plus plus, so that's 3 squared. Oh good, I'm glad I can do this in my head. So the square root of 25. So our distance between those 2 points is 5. That's our radius is 5. And we have to square it. So 25. So this is the equation of a circle with center of -3, -5, and it passes through the point 1, -2. Now that's not the only way you could have done this problem. You could have plugged in the point 1, -2 for x and y and solved for r. That would have worked too. I used the distance formula. If you want to see some other videos, you have the QR code right here that you can check out, or if you're not sure about some of these, come see me at the help session.